All right, so today we're going to talk about hybridization. Hybridization is very important in organic chemistry, and it's all about being able to tell the hybridization of a carbon atom. And this is very important because hybridization can tell you many of things. It can tell you a carbon's geometry. It can tell you the bond angle between the carbon and its next door atom. And so this can lead you to help determine its reactivity. And so it's very important foundational concept that you need to understand when going into organic chemistry. You need to be able to, when you look at an atom, to automatically know what its hybridization is. And so there's three types. There is sp3, sp2, and also sp. And these are the three that you need to be really familiar with. Okay, and so let's go a little bit about why this is important. Okay, so I'm going to draw an energy curve here. So increasing energy going up. Now, these hybrid orbitals, sp3, sp2, and sp, are hybridized from atomic orbitals. So for an example, you have, let's say you have your s orbital and you have your three p orbitals, so s and p. All right. What happens is these orbitals rehybridize to give you four new hybridized orbitals that are now sp3. And if you notice, these are lower in energy. And so this is how this concept works. You have your atomic orbitals. So these are your atomic orbitals here. And they rehybridize to give you your hybridized orbital that are lower in energy. Okay. And so let's go over the orbitals that make up each one. So for sp3, let's do sp3 in blue. So for sp3, you have an 1s plus 3 p's give you 4 sp3s. Okay. For sp2, you have 1s plus 2 p's give you 3 sp2s. But notice we're still missing something, right? We are missing a p orbital, all right? So this orbital here remains unchanged, so not hybridized. Okay. And then finally, we have 1s plus 1p orbital gives you 1 sp orbital plus 2 p orbitals, or 3 p orbitals, excuse me. Two p orbitals. There we go. 2 p orbitals. Okay. Now, notice that in all these cases, that 1s and 3 p's equals 4. So that's our 4 we originally started with. Here we have 2 p's and an s, that's 3, plus a p, that's 4. So that's our 4 we started with again. And then on the sp orbitals, we have 1s and 1p, and then 2p orbitals. So that again equals 4. So we know that this is correct. All right. And so our atomic orbitals, right? So an atomic s orbital, just looks like a sphere. All right. So if we were to draw it, it would look like a sphere. And then our p orbital looks like what we like to call a dumbbell. Okay. And you can have a P in the X direction, the Y direction, and the Z direction. So in all three dimensions, okay? That's why you have three up shown over here. Let's do this. I don't like that. You get one that's the X, the Y, and the Z axis, okay? Now, when these rehybridize, again, right, so they're going to hybridize to form an sp3, sp2, or sp. You get an orbital that looks something like this. So you get where it has a lobe on one side that's bigger than the other side. And so this is the hybridized. So this is the new hybridized orbital here. Okay. And so no matter if you have an sp, sp2, or sp3, those hybridized orbitals look like that. Okay. Now let's talk about what it looks like in terms of molecular orbital theory. Okay, so if we were to have a carbon and it was bound to another carbon, and let's just say this is bound through sp3, so we're going to say sp3. Okay, it would look something like this. We would have our little lobe back here, have our big lobe, have a big lobe here, and a little lobe. All right, these are overlapping head to head. All right, and when orbitals overlap head to head, you get what's known as a sigma bond. So we get a sigma bond. All right, and so you get a sigma bond for each thing that it's bound to, right? So here it's carbon to carbon, but you would also have one to a hydrogen here, hydrogen here, hydrogen here, hydrogen, hydrogen, and hydrogen. Okay. Now, for sp2, right? For sp2, very similar. Again, you have, so we have carbon to carbon. You have that big one, and then that little one, the big one, and then the little one. So this is your sigma bond. But now you have that extra p orbital, right? So that has to be somewhere. So and that actually goes here. And that forms a bond like that. And this is known as a pi bond. So in an sp2 hybridized carbon atom, you have a sigma bond and a pi bond. All right. Now let's talk about sp. So for sp, all right, so our carbon atoms, all right, so here we have our sigma bond. We'd also have an extra p orbital, right? So there's our pi bond. But now we have another one. We have another p orbital extra, but now it's going in another direction. So it's going in this direction. I know this is really hard to tell, but it's going in that direction right there. And that gives you another pi bond. So you get another pi bond. And so if we were to look at these, we would say, okay, sp3 has a sigma bond. sp2 has a sigma bond plus a pi bond. Make that look a little bit better here. And then sp has a pi bond, 2 pi bonds, and a sigma bond. All right. And so that's important. Okay. Now, one of the questions that students often have a hard time being able to determine is, well, how do I know if it's a pi? Or, how do I know if it's sp2, sp3, or sp? Simple. It depends on if you have a single bond, double bond, or triple bond. All right? So, sp3 is single bonds. So you'd have something like ethane or methane, something like that. All right, just any carbon chain. sp2, you would have a double bond, so something like ethene. And then for your other one, for sp, you would have something like acetylene, so a triple bond. So all you have to do is look and determine what the how many bonds the carbon has to it, and that will tell you its hybridization. All right, so now let's do a little bit of practice. All right, so if I draw something like this, let's see. And that. All right, so now let's look at these and determine what type of hybridizations we have in each one. All right, so for the top one, all of these carbons here are single bonds, so these are sp3. Here, all the carbons have a double bond, so these are sp2. See how easy that is? If we look at this one, that's double bond and double bond. This is a double bond and this is a double bond. So these are all sp2. And now, these here, right, these are sp3 because they're single bonds. And then finally, the last one, right here, so this is sp3, sp3. Then these two here would be sp, right? And so that is how you determine the hybridization of a carbon atom.